Hello my dear students, I am B S Pandey, your physics lecturer. My dear students, we are studying chapter number 7 of NCERT. It is alternating current. Okay, we have studied till now about the RMS value, peak value, their relation and the resistive circuit when we apply the AC to the resistive circuit, pure resistive circuit, then how the EMF and voltage correlates. We have also calculated the average and instantaneous power for that resistive circuit. Today's lecture, my dear students, we are going to continue with the phasor diagram, and then we'll continue the pure inductive circuit, that it will apply all AC current, alternating current, to the inductor. Alright, so let's start today's lecture, the lecture number 75. Of chapter 7 NCERT. It is alternating current, and today's topic is phasor diagram. It is the first topic, the phasor diagram. Then we'll continue for the next topics. Okay, my dear students. Now, the concept, this phasor diagram, why this concept were used, and before that we should know what is this phasor diagram. So, my dear students, look at here to the marker. If this marker having some particular length, alright, and we use this particular marker for the representation of its magnitude as well as its rotation, that is the direction. So we can say this is a vector representation. In similar way, the current and voltage in AC circuit actually do not move with only the magnitude. It was found after number of observation, number of experiment, that in few circuits, AC circuit, the current and voltage phases differ by certain value, and due to the difference of phase, remember, don't be confused with the phase, my dear students. I'm telling you again, because we have studied about the phase in standard 11th already. So it was found that for current and voltage, if phase differ by some amount, then the quantities also changes. But number of observation and the experiment give the concept. If we will use the vector method, then it would be easy to study this alternating current circuits, AC circuits. That's why this phasor diagram used. And phasor is what? So the phasor is the vector representation of current and voltage using a phasor rotator, nothing else. So phasor is the vector representation of voltage and current. For example, if I am giving you the current in any circuit with the peak value as 5 ampere, then I'll represent, or we will use the length of the phasor as the 5 ampere. If we are using the voltage as of 4 unit, then we'll use another representation of shorter length. If it's of the 5 unit of such length, then 4 unit will be little shorter. Okay, and using this type of representation, we are going to study here the AC circuit, and this concept were known as the phasor diagram. So you can write in one line about the phasor diagram. It is the vector representation. Okay, this is nothing but the vector representation of what? Of voltage and current. Okay, voltage and current. So this is the vector representation of voltage and current, and this is called the phasor diagram. Now, phasor diagram, if you are taking, suppose if this is the length of E naught or ET, okay, suppose E naught, the maximum value, then I naught will be little shorter. Why? Do you know why? Because we know that the amplitude of current will be smaller than the amplitude of voltage. We have discussed already. Okay, my dear students? Yes, I have told you. Now, if it is the vector representation, it means the length is representing here the magnitude, that is the peak value. We can write length is representing the magnitude, that is the peak value. We are writing about the phasor, the first point. Okay, so you can write the length of phasor represent the peak value. It is the peak value. If this phasor is placed in this way, E naught along the x-axis, then you can say this phasor, if it is the vector representation, if it is the vector in which this is the head and this is the tail, if it is the vector, then you can say here angle with the x-axis is 0 degree. Here in this way, the angle is how much? It is 0 degree. Now, in this case, if it is x-axis and the phasor is like this one, E naught, then you can say the theta is 90 degree. Okay, this is for this one and this for this one. Here you can say theta is 90 degree. Actually, what is this 0 and 90? So these two are called the phase. Okay, these are called the phase. Here, phase of voltage with x-axis. Now, x-axis is not a physical quantity. So we have to take any physical quantity along the x-axis to speak about the phasor or the phase of voltage. We will study right now. Here the phase of voltage you can say with the x-axis is 90 degree. Alright. So this is the concept of phase. Now the next point about the phase, that is very important. The vertical component, if this phase is rotating, this phase can rotate. If this is the 90 degree, actually how much it rotate and how it rotate in this way. So this is the 90 degree. If this phase represented in this way, this is the x-axis and this phase is represented in this way, E naught, then you must go in this way. So the theta will be minus 90 degree. Now the phase is minus 90 degree. Okay. So here we can say that if any phase rotating anti-clockwise, okay, if any phase is rotating anti-clockwise, like here this way or this way, rotation phase rotating anti-clockwise like this one. Okay, so positive phase, and if it is rotating clockwise, then it will be the negative phase. This is the concept, okay, that you have to remember. If I rotate any phasor like this way, theta, this will be the, suppose any quantity, suppose E, theta, this is the positive. If I rotate the same quantity, this will be the minus theta. Actually, this I want to say by the point. Now the next point, the vertical component, suppose if we have rotated this phasor by this value, then it have the component over the vertical axis, that is y-axis, and this vertical axis gives some quantity actually. Okay, you can say, my dear students, its length is not going to be changed, E naught, this length is not going to be changed, this length will not change, peak value doesn't change. Okay, but as it will rotate for each theta, this length, that is on or along y-axis, it will change for each second, for each time, and that will give you the instantaneous value of that quantity. So you can write the vertical component gives instantaneous value. Okay, vertical component gives instantaneous value. So this is the concept of phasor. Now we will try to understand how to make the phasor, and the phasor actually how to draw for any circuit. We have studied already the resistive circuit, so we are going to plot the phasor of that resistive circuit. But you have to keep these points in your mind very carefully while drawing the phasor diagrams. Phasor diagram of pure resistive circuit, let me draw. I hope you understand about this phasor diagram, my dear students. I am going to draw here the phasor diagram of resistive AC circuit. What we have studied for the voltage and current in resistive circuit, my dear student, the ET was E naught sin omega t and IT was I naught sin omega t. Am I right? And we have also discussed, if it is phi 1, which is omega t, and if it is phi 2, which is also omega t, so delta phi, which is phi 2 minus phi 1, it is 0. That is the phase difference. Phase difference is 0. Okay. Now, for resistive circuit, we are going to draw here the phasor diagram. We will take the phasor of voltage of this length and phasor of current of this length. Okay. How much we have to rotate the phasor of voltage? Look at here for the equation. It is E naught sin omega t. Okay. E naught sin omega t. If this is E naught, how much it should rotate? It should rotate omega t. Okay. And if we will take current, how much that will rotate? It will rotate the same value. I'm trying to represent here. This is the same, and this is I naught. I naught. Okay. Now the vertical component. This vertical component of I, it will gives you the instantaneous current, and this will give you instantaneous voltage, that is the 80. This was the concept. Actually, I was telling you. The vertical component will give you the instantaneous value. Here the vertical component, if it will rotate little more, then it will increase, and this component will be maximum. This component will be maximum when this will rotate for how much? 90 degree. Even you can put the value of here omega t as 90, you will get it will be maximum. This it will be maximum for 90 degree. Okay, so this is the way simple. Now in same way you will plot the phasor of different circuits. I hope you understand how to represent the phasor. Okay, now we are moving to the next topic. It is the AC applied through inductor, that is the pure inductive circuit. Let me grab this. AC across, you can give the heading, my dear student, AC across, or you can write the inductor under AC supply. You have studied already about the inductor in electromagnetic induction chapter number 6. Okay, this is inductor, AC source, E naught sine omega t. This is inductance L. Instantaneous current IT flows through the circuit which works as input. Now applying KVL, my dear students, we can write here E naught sine omega t minus how much voltage drop across the inductor. Do you remember, my dear students? That is called the back EMF. Do you remember? Yes, it is minus L di by dt, and the modulus will be this much. This is the drop voltage over the inductor. So we can write L di by dt, and there is nothing on which the voltage drops, so it will be equals to 0. E naught sine omega t is equals to L di by dt, or di can be written as E naught by L sine omega t dt. We have to find here the value of I, so we'll integrate with proper limit. This is all about the constant. Di will be I. Since this is the instantaneous value, the current will be instantaneous. E naught by L, am I right? And sine omega t dt. Okay, sine omega t dt. So the integration of sine will be minus cos omega t divided by omega. We can write E naught by L omega minus also there cosine omega t. This is the instantaneous value, or this can be also written as, because this is minus cos omega t, so we can write, my dear students, it as E naught by L omega in terms of sine. This one is also the very important equation, remember. But we can write in terms of sine. Why we are going to represent in terms of sine? Because we know that the phase of voltage, it is with the sign. So we are converting in sine to compare easily the phase of these two quantities. And this will be omega t minus pi by 2. Minus sine theta can be written as the sine theta minus pi by 2. Okay. So this will be the equation. Now you can see, if this is the IT which is current and this is a number, so this should be also the current. Am I right? This should be current. And how is it possible if this is current? And how it becomes current? If it is current and this is voltage, of course this quantity which is dividing voltage must be a resistance, or like resistance. Like resistance? Yes, this is resistance, my dear students. And this resistance is called a special name L omega. This is called XL, which is reactance. Reactance. It is similar as the resistance offered by inductor. Its SI unit also same as the resistance, which is ohm, and this is called XL, inductive reactance. Inductive reactance, which is L into omega. Okay, my dear students. So the current I can be written as, let me grab this. Current I can be written as, which is peak value I naught. Here you can write I naught, it is E naught by XL. Could we write, my dear students? Now we are going to discuss over this equation for 2 or 3 point. What is that? It is, if we discuss, my dear students, please keep in your mind this equation, which is very important. Later on I will discuss over this equation also. I naught E naught by XL. For AC, we know that the frequency, it is in our India 50 Hertz, which is very high value. Okay, and XL is L into omega, which can be also written as L into 2 pi f. Am I right? If this value will be larger, this I naught will be smaller, so the current will be smaller. If it is larger, it means it resisting the current with its maximum value. If it is very high, it means it is capable to block the current. Am I right? If it is very high, then this will be able to block the current. Here, this inductive circuit, actually inductor blocks the AC. Inductor blocks the AC. Why? If this value will be much higher, the current will be how much? Lower, almost 0. If this is very high, then this will be the very small and approaching to 0. It means what this inductor is doing? Inductor is blocking the AC current. Kindly note down in note point, inductor blocks AC current. Okay, now discuss for the, let me discuss for the DC current. For DC supply, what will happen? We know that the frequency of DC source, it is 0. It means XL, it will be how much? 0. And XL 0, it means no resistance offered by inductor for DC current. It will not obstruct, it will not stop. If the current is coming, so the maximum current will flow through the inductor without any hindrance. So it does not block the DC current. It easily allows the DC current to flow through it, but it always blocks the AC current, remember. Okay, and because it blocks the AC current, the energy waste in form of different form, okay, in form of electromagnetic wave, you can say, the heat energy, you can say, okay, that is the use of this inductor in AC circuit. Okay, now here we were about to talk on this particular thing, the phase of current and the phase of voltage. Look at here, Et is E naught sin omega t, whereas It is I naught, this become I naught now, I naught sin omega t minus pi by 2. You can see the phase of current is lagging. The phase of current will behind by pi by 2. If in your examination the question is asking, prove that current lag by pi by 2 with the voltage in inductive circuit, then you can prove by using this calculation. This is not very difficult. But here the phase difference, you can write minus pi by 2. This is the phase difference. I don't think that I need to explain in very detail now about the phase difference. Okay. Now, could you make the sinusoidal graph? Because you have to make the sinusoidal graph, then phasor diagram, and you have to also calculate the instantaneous power and average power. Here the instantaneous power will be PT can be written as Et into It, which is It is E naught sin omega t and It is I naught sin omega t minus pi by 2. This is PT, or you can write in terms of cos also, average power. So the average power we can write PT dt over dt. Am I right? Yes. Now PT dt, it is E naught sin omega t times minus I naught cos omega t. Could we write? Yes, we can write. Divided by dt for full cycle, it will be the t. Now look at here. To integrate this value E naught I naught constant, we are having here the sin omega t into cos omega t. My dear students, multiply and divide by 2. It will be convert. Here the dt we are living with minus E naught I naught by 2. This will be sin 2 omega t. I hope you understand. Now try to think how it becomes. This equation. Yes, 2 sin theta into cos theta minus E naught I naught by 2t integration of sin 2 omega t, it will be minus and minus plus cos 2 omega t divided by 2 omega from 0 to t. You will put the value, you will get 0. What is going on? My dear students, look at here the result. Here there is a current in the circuit, but power is 0. And for the circuit in which current is flowing but power is not consuming, here the power consumed is 0. So that type of current is called waterless current. For P equals to 0, current is termed as waterless current. So the current flows through inductor, it is waterless current in steady. Now, my dear student, we are going to plot the phasor diagram and sinusoidal curve. So you can plot the sinusoidal curve. I know that I am leaving that particular topic for you as a homework to plot the sinusoidal curve. Okay, I am drawing here the phasor diagram of this one. Phasor diagram. This is T or omega. If we take voltage of this length E naught, so I naught will be smaller, we know very well. Let me rotate the voltage phasor by omega t. How? Et was E naught sin omega t, but It we got I naught sin omega t minus pi by 2. Am I right? If this is E naught and this is the Et, how much it rotated omega t, then I am going to rotate I naught. If this is I naught, the red one, okay. So I naught has to rotate how much? Omega t, and then it has to move back by pi by 2. So it will rotate omega t minus pi by 2. It means finally the pi by 2 will be the perpendicular to this E naught. And this is the I naught. How much it value? It is pi by 2. But this much angle is total omega t minus pi by 2. This one is okay. So remember, and this will give you It, that is the instantaneous value. This is the phasor of voltage current of inductive circuit under AC supply. Okay, my dear students, in next lecture we will study about the graph of reactance. We will discuss later on in next lecture, and we will try to solve few numerical questions as well. Okay, so let me conclude today's lecture number 75. Okay students, thank you very much.